A flowchart is a diagram showing an algorithm as a sequence of steps, and the shape of each box tells you what kind of step it is. There are 6 symbols on the syllabus, and learning them takes about a minute, so the useful thing is not the list, but the question each shape answers. The terminator, a rounded rectangle, marks where the algorithm begins and ends. Every flowchart needs exactly one start and at least one stop. The parallelogram is input or output, data coming in from a user or going out to a screen. The rectangle is a process, a calculation or an assignment, something the algorithm does to a value. The diamond is a decision, a question with exactly 2 answers, yes and no, and it is the only shape with more than one arrow leaving it. The elongated hexagon is a subroutine or predefined process, a call to a separate block defined elsewhere, and arrows, or flow lines, show the order in which steps happen. So the choice is decided by what the step actually does. Is it moving data in or out, changing a value, or asking a question? 2 pairs cause almost all the errors, so be deliberate about them. First, parallelogram against rectangle, input-output against process. The test is whether data crosses the boundary of the program. Input age crosses it, so parallelogram. Output total crosses it, so parallelogram, but total equals total plus num happens entirely inside, changing a value the program already holds, so that is a rectangle. Ask, is this data arriving or leaving, or is it being changed in place? Second, the diamond. A decision has exactly 2 exits, labeled yes and no, or true and false. If you find yourself drawing a diamond with 3 arrows out of it, the condition is not a yes or no question and needs splitting into 2 decisions. And label both exits. An unlabeled diamond is ambiguous because a reader cannot tell which branch is which, and it costs the mark even when the logic is right. Look at the pass-fail example on the page and follow it as an algorithm rather than as a picture. Start in a terminator, then a parallelogram, input the mark, then a diamond asking whether the mark is greater than or equal to 50. If yes, the flow goes to a parallelogram outputting pass. If no, to a parallelogram outputting fail. Both branches then join and reach stop. 2 things worth noticing there. The branches rejoin. They do not each run off to their own separate ending because the algorithm has 1 exit, and the decision is written as a condition that is either true or false, mark greater than or equal to 50, not as a vague question like is the mark good. That precision is what makes a flowchart translatable into code. A well-drawn flowchart can be turned into pseudocode almost line for line, and that is a fair test of whether you have drawn it properly. Loops are where flowcharts differ most from the pseudocode you may be more used to because there is no for or while keyword. A loop is drawn as an arrow going backwards. A conditional loop is a diamond whose no branch or whose yes branch leads back up to an earlier point in the flow. So a while loop becomes a decision at the top with 1 exit continuing into the loop body and the other leaving, and the end of the body arrows back up to that same decision. A counting loop is the same shape with a counter. Set the counter before the loop, increment it inside the body, and test it at the diamond. The thing to check on any loop you draw is that the arrow returns to the right place. Returning above the initialization resets your counter every pass, and the loop never ends. Returning below the test skips the check, and it also never ends. Trace it once with real values, and you will see immediately which it is, which is the technique from the trace tables lesson used on your own diagram. The drawing rules, and each corresponds to a way marks go. Flow normally runs top to bottom and left to right, so a reader can follow it without hunting. Every symbol except the terminators has at least 1 arrow in and 1 arrow out. A box with no way in is unreachable, and a box with no way out is a dead end. Arrows have arrowheads. A plain line does not say which direction the flow goes. And in a diagram containing a loop that genuinely matters, decisions are labeled on both branches. Text inside a box is short and specific, a variable name and an operation, not a sentence, and there is exactly 1 start. If your flowchart has two starting points, you have drawn two algorithms. So how do you produce one from a written problem? Work in the order the algorithm runs, not the order the question describes things. Identify what must be input, which gives your parallelograms. Identify what must be calculated, which gives your rectangles. Identify every point where the algorithm has to choose, which gives your diamonds. Identify what must be output, then connect them in execution order and add start and stop. Take a problem, input 20 marks, count how many are 50 or above, and output that count. Before the loop, set count to 0, a process box. The loop runs 20 times. Inside, input a mark, parallelogram, then a decision. Is the mark greater than or equal to 50? If yes, add 1 to count, a process box. If no, skip it. Both branches rejoin, and the loop arrow goes back. After the loop, output count. Notice that setting count to 0 had to happen before the loop, not inside it. Putting an initialization in the wrong place is the commonest structural error in this topic, and tracing the first two passes catches it every time. 4 things to take into the exam. First, use the right shape for the right job, parallelogram for input and output, rectangle for a process, diamond for a decision, and remember the test. Is data crossing the program's boundary or being changed inside it? Second, label both branches of every decision. Third, make sure every arrow has an arrowhead, and that loops return to the correct point, above the body but below any initialization. And fourth, keep the text inside each box short and precise, using the variable names from the question. Examiners are checking that your flowchart could be turned into working code, so anything a programmer could not act on, a vague instruction, an unlabeled branch, a missing arrow, is what costs you.